Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NI EVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Basic. Today, I am going to take a physics class for class 9 students. My dear students, our today's topic, Chapter 3, CQ1 and Extra CQ. Our today's lecture number is 22 and HW number 19. So let's start our class. This is chapter 3, force. Chapter name is force. Okay. Chapter 3. At first we will discuss CQ1. Let's see the step. Farooq pulls a box of mass 4 kg on the floor with a constant force. The frictional force between the box and the floor is 1.5 Newton. While pulling, the box accelerates at 0.8 meter per second square. Then the box is pulled with the same force on a frictionless floor. Question number A. What is a balanced force? My dear students, we know we have learned already this definition while reading done. Okay, so let's see what is a balanced force. We know if the resultant of applied force is equal to 0, then it is called balanced force. If the resultant of applied force is equal to 0, then it is called balanced force. Now come to question number B. Why is the frictional force generated? Answer will be friction is the consequence of the surface irregularities of any two surfaces. Though the surface of an object seems to be smooth, apparently there are high and low grooves on it. In fact, when an object moves on another object, the grooves of both the surfaces catch onto one another, and this is why frictional force is produced. Now come to question number C. Next question. What is the force applied to the box in the first case? Question is, what is the force applied to the box in the first case? My dear students, now come to step again. Here given Farooq pulls a box of mass 4 kg. That means the mass of the box is 4 kg. Here given mass of the box is 4 kg. Then 4 kg on the floor with a constant force. The frictional force between the box and the floor is 1.5 Newton. So my dear students, here also given while pulling the box accelerates at 0.8 meter per second square. That means here given acceleration is acceleration A 0.8 meter per second square. And we have to find out the force. What is the force applied to the box at the first case? So my dear students, here given question number C. Here given M mass of the box is 4 kg and acceleration A is 0.8 meter per second square, and we have to find out the force. So we know from this from here we know the formula F equals to ma. Okay, so now put the value 4. A means 0.8. Okay, so it will be 3.2 Newton. That means force 3.2 Newton. But here also given the frictional force between the box and the floor is 1.5 Newton. Okay, so you have to write here the frictional force between the box and the floor is 1.5 Newton. So we have to find out what is the force applied to the box in the first case. So the force applied to the box in the first case, it will be this force, that means 3.2 Newton plus given this this force. Okay, the frictional force between box and the floor is 1.5 Newton. That means it will be 4.7 Newton, and this is the force applied to the box in the first case. Okay, my dear students, now come to next question. Question number D. What is the change in acceleration in frictional and frictionless force? What is the change in acceleration in frictional and frictionless force? Explain mathematically. Okay, now let's start this question answer. Question answer D. Acceleration is higher in case of a frictionless floor. We know acceleration is higher in case of a frictionless floor, and then that of a frictional force, even though the same force is applied in each case. In case of the frictional floor, acceleration is here given in the CQ. In case of frictional force, the acceleration is given 0.8 meter per second square. Okay, here this is the given in the stem. In case of the frictional floor, acceleration is given 0.8 meter per second square, and while frictional force is 1.5 Newton. This is also given in the stem. Okay, while frictional force is 1.5 Newton. If the floor were frictionless, then the frictional force would be would not act, and the net force would be, then the net force will be, we will find out this net force, it will be 3.2 Newton plus 1.5 Newton. Okay, this is the given in the stem, that means 4.7 Newton, and we have already found this value in the question number C. Okay, so net acceleration would be, we have to find out the net acceleration. So we know F equals to ma, and we give A equals to F divided by m. Here given F means 4.7 Newton. Okay, F equals to 4.7 Newton, and m is 4 kg. So it will be 1.175 meter per second square. Okay, this is the net acceleration. And now we have to find out, the question is what is the change in the acceleration in frictional and frictionless force. Okay, so now we will find out the change of the acceleration. Okay, so change of the acceleration, it will be this acceleration and minus this while pulling the box accelerates, they are given another acceleration, that means 0.8 meter per second square. So this is the change of the acceleration. So it will be A equals to 1.175 minus 0.8. Okay, minus 0.8, and that is given in the stem. That means it will be 0.375 meter per second square. Okay, and this is the answer. What is the change of the acceleration in frictional and frictionless floor is 0.375 meter per second square. My dear students, now come to next CQ. This is extra CQ. I have given this here an extra CQ, and extra CQ. The stem is a truck of mass 1200 kg was moving with 20 meter per second velocity, but on the way driver lost its control and collided with a static car of mass 1000 kg near the road. After collision, the truck and car slided together for 150 meter before stopping. My dear students, now see the question here. Question number B, explain G, capital G. It is capital G. That means all of you have known this. This capital G means gravitational constant. Okay, so you have to explain this about this gravitational constant, and we know at first you have to say the laws of Newton's gravitational law. Okay, so we know the Newton's laws of gravitational is F equals to G m divided by r square. Okay, and here G is the gravitational constant, and we know the G, the value of G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, and you have to explain this. Okay, now question number C, determine the combined velocity of truck and car. And my dear students, I think all of you have understood this question. You have to, at first you have to write the given, here given the mass of the truck, this is m1, is 1200 kg. Then the mass of the car, this is M2, okay. M1 given, M2 also given here 1000 kg. Then this is the velocity, that means the initial velocity of truck, okay. Here U1 is given also 20 meter per second, but the initial velocity of the car, this U2 is 0, okay. And here given after collision the truck and car slided together for 150 meter, that means you have to find out the combined velocity. So combined velocity V equals to what? And I think all of you have understood which formula is appropriate for this mathematical problem. Okay, now come to question number D. Is it possible to find out the resistive force of the moving truck from the above information? I am repeating, is it possible to find out the resistive force of the moving truck from the above information? Explain it with mathematical logic. My dear students, I think all of you have understood this one. We know the resistive force is here F equals to ma, okay. F equals to ma, and this for truck, that means the here m is 2000, here m is given, the mass of the truck is 1200 kg, okay. And A is also given 20 meter per you have to find out the A, value of A, and here distance S is given, 150 meter, and you have to follow use this formula V square equals to U square minus 2AS, because they are given distance, okay, and it will be minus because here is retardation, okay. So use this formula, then you have to find out the A, and then you have to apply this formula F equals to ma, and then you can easily find out the force. This is the resistive force, okay. So my dear students, I think all of you have understood and this topic, and your SW, I am giving your SW, your SW number is 19, and your SW topic is, this is extra CQ, okay. That one is your SW topic, extra CQ, and submit it on the Saturday. My dear students, I hope all of you have understood our today's topic properly. Memorize and practice properly at home this 2 CQ, and do your SW this as this extra CQ, and submit it regularly. See you again in the next class. Allah Hafiz.